Hi, this is Mrs. Bazin, and in this screencast we're going to talk about the properties of the different groups on the periodic table. The first group we're going to look at are the alkali metals, so this is group 1. So this is our first column on the periodic table. So even though the elements are different going down in this column, they all have very similar properties. So if you know the property of the group, then I could ask you about any element within that group and you could give me the properties even if you weren't completely familiar with that particular element. So the alkali metals are very soft solids at room temperature. For example, sodium metal, which we'll look at in class very carefully, it could actually be cut with a knife. It's a metal, and when you cut it, you can see that it's very shiny, but it's very soft. They're also very reactive. So the other thing when we look at a little bit of sodium, you will see that it's not something we can just store in a container on the shelf. It's something that has to be stored in oil because it's so reactive that it will react with the moisture in the air. Another property of alkali metals is that they will all react with water to produce hydrogen gas, which is flammable, which is another reason that these are very dangerous, and a metal hydroxide, which is a strong base, again, a substance that can be dangerous as well. Because they're so reactive, you would never find these metals in pure form, so they don't mine for pure sodium or pure lithium. They mine for the ores, and then they're able to purify those elements from those metal ores. The next group is the alkaline earth metals, which is group 2. These are harder, denser, and stronger than group 1. They have higher melting points compared with group 1, but they are still very reactive. Not as reactive as group 1, but you still would not find these free in nature. So these again would be things that would have to be mined as ores and then purified. Transition metals are that group in the middle, kind of the transition between the metals and the nonmetals. They're good conductors of electricity, so you'll see a lot of the things that we use for wires and conductors are in this group. They are very shiny, they have very high luster, and they're much less reactive than groups 1 and 2. So if you think about some of the things in these groups, the jewelry metals, gold, silver, platinum, copper, titanium, those types of things, those are things that you often find in their pure form. You can get pure gold or silver or platinum. We can carry it around in our pockets, we can wear it, and we don't have to worry about it reacting like we would things with group 1 and group 2. So some of these are found as free elements in nature. The next group we're going to look at is group 17. Those are the halogens. This is the second to last group. These are the most reactive nonmetals. These tend to react with metals to form salts. Especially they tend to react with metals in group 1. So an example in halogen, one of the halogens is chlorine. And chlorine, as you know, is usually found, or a lot of times found with sodium. So sodium's a group 1 metal. Chlorine's a halogen, which is group 17. So those two things are often found together. Next group are the noble gases. These are all gases. These are unreactive. The person that discovered these, the guy's name was Sir William Ramsay, he called them the noble gases because he felt they acted like noble people. The nobles didn't like to associate with the other people, so he called them the noble gases because they were elements that didn't like to associate with the other elements. Now there are some that in laboratories they can actually have them create compounds. There's a lot of compounds that they can actually force to occur, even if they don't naturally happen that way. And these are found in pure form in nature. And again, as an example, to see how unreactive they are, if you think about something like helium, helium is very unreactive. You can let little kids carry it around in a balloon. Whereas you have something like hydrogen, which is over on the other side in group 1, very explosive, not something you would want people carrying around. The next group are the lanthanides. These are those elements at the bottom that we looked at in the last screencast. These are in period 6, but they're pulled out at the bottom because they were discovered after the main arrangement was made. These are shiny metals, and they're very similar in reactivity to the alkaline earth metals. They're very similar to group 2 in their reactivity. Okay, ignore on that previous slide. Okay, don't worry about this for now because we're going to put that onto those you're actually going to get on the next slide here. Okay, so here's the actinides. This is the next group down, or the next row down. These are elements 89 through 102. These are radioactive, and most of these are laboratory made. There are a couple that are found in nature, but most of these are laboratory made. Okay, so let's look at a couple practice problems here, how you might be able to use this. So once again, we can see where all the different elements are. But what we could do is, let's say I gave you an example and I said, okay, what about calcium? If you find calcium on the periodic table, what could you tell me about it? So you are not going to memorize the individual properties of each element, but you will memorize the properties of the group. Okay, so we know that calcium, in general, it's on the metal side. Okay, so again, the metals are on this side, and then the non-metals are over on this side. And the stair-step line is what separates them from each other. So we could say, okay, we know calcium is a metal. Another thing we know about calcium is that its atomic number, or its Z number, is 20. And then specifically, we know that it's an alkaline earth metal. Okay, and knowing the properties of alkaline earth metals, we could say calcium is probably not going to be found in pure form in nature, and it's probably something that is pretty reactive. Okay, so let's do another example. Let's take something like copper. Okay, so Cu. So we could also, by its position on the periodic table, we could know that copper is a metal. More specifically, copper is in the transition metals. Its atomic number is 29. And then knowing what we know about the transition metals, even if we didn't know what copper was, we could say that copper is a good conductor, copper is fairly non-reactive, and most likely found in nature in its pure form. Okay, last example, let's go to neon this time. So we're going to look at neon. So neon, we know, is a noble gas. We could also classify it as a non-metal because of its position. And then the other thing we know about neon is its atomic number is equal to 10. Also, since we know our properties of noble gases, we could say that neon is found in nature in its pure form, and that neon is very unreactive, and that neon is a gas, as its name implies.